Have you ever wondered how the immense power of the atom is harnessed in a nuclear power plant? In the vast universe, power is everywhere. But one of the most potent forms of energy is hidden in the tiniest particles we know: atoms. Yes, nuclear energy, residing in the core of these minuscule atoms, holds a tremendous amount of power waiting to be tapped. Now, let's delve into how we harness this energy in a nuclear power plant. It all starts with a special type of atom known as uranium. This atom is unique because it is unstable, meaning it can be split apart. When we split a uranium atom, it releases a colossal amount of heat energy, which is what we call nuclear energy. This nuclear energy is a powerhouse that has the potential to generate vast amounts of electricity. And that's precisely what happens in a nuclear power plant. Now, wouldn't it be exciting to understand how we transform this atomic energy into electricity? So, what fuels these power plants? It's a heavy metal called uranium. Uranium, found in trace amounts in rocks, soil, and water, is a dense, silvery white material that is radioactive. When mined and processed, it becomes a potent source of energy. This energy is harnessed in nuclear power plants through a process known as nuclear fission. But how does this happen? Well, think of uranium atoms like a fragile glass sphere. When struck by a neutron, this sphere shatters, releasing a tremendous amount of energy. This energy, in the form of heat, is what drives the turbines in a nuclear power plant, generating electricity. But uranium isn't just about raw power. Its energy density is staggering. A single pellet of uranium fuel, about the size of a pencil eraser, can produce the same amount of energy as a ton of coal or 3 barrels of oil. This uranium undergoes a fascinating process known as nuclear fission, which we'll delve into next. Nuclear fission, the heart of a nuclear power plant, is a process that splits the nucleus of an atom into smaller parts. Now, this might sound a bit complex, but let's break it down a bit. Imagine a tiny particle, a neutron, hurtling at high speed towards a larger atom, usually uranium or plutonium. The impact of this collision causes the larger atom to split, or fission, into 2 smaller atoms. What's really fascinating about this process is that it doesn't just result in the creation of smaller atoms. It also releases a large amount of energy. Picture it like a cosmic pinball machine, where the split atoms release more neutrons, which then collide with other atoms, triggering more fissions. This chain reaction is what keeps the process going, releasing more and more energy with each successive split. But how does a nuclear power plant harness this energy? Well, it's all about heat. You see, the energy released during nuclear fission is primarily in the form of heat. This heat is then used to boil water, creating steam. If you've ever seen a kettle boil, you've seen a similar process in action, just on a much smaller scale. The steam produced in a nuclear power plant, however, is not for brewing a cup of tea. Instead, it's used to turn a turbine. This turbine is connected to a generator, and as it spins, it generates electricity. So, in essence, a nuclear power plant is a giant, sophisticated kettle. It uses nuclear fission to heat water, which turns into steam, which then turns a turbine to generate electricity. It's a remarkably efficient process, capable of generating vast amounts of power from a relatively small amount of fuel. But remember, while nuclear power is incredibly potent, it also comes with its share of challenges and responsibilities. Ensuring the process is controlled and safe is of utmost importance. So we've used nuclear fission to create a lot of heat, but how do we transform this into electricity? Well, that's a tale for the next chapter. Stay tuned. Transforming the heat generated by nuclear fission into electricity is actually a simple process, similar to that used in many other types of power plants. Let's break this down to make it more understandable. Picture this. Our nuclear reactor has just produced a tremendous amount of heat through a process called nuclear fission. Now, what do we do with all this heat? The answer is simple. We use it to boil water. That's right, just like making a cup of tea. But instead of a kettle, we're using a massive pressure vessel. Within this pressure vessel, the heat from the nuclear fission is transferred to water. The water starts to boil, and as it boils, it transforms into steam. But this isn't your regular steam. This steam is under extremely high pressure, and it's this high pressure steam that we need to generate electricity. Now imagine a windmill, but instead of wind, we're using this high pressure steam. This steam is directed towards a series of large blades, collectively known as a turbine. The force of the steam spins these blades, and as the blades spin, so does a shaft that's connected to them. This spinning shaft is connected to a machine known as a generator. Inside the generator, the spinning shaft spins a set of magnets around a coil of wire. As the magnets spin, they create a moving magnetic field around the wire. This moving magnetic field induces a flow of electric charge or current within the wire. And voila! This current is our electricity. It can be sent out to homes, businesses, and industries, powering everything from your refrigerator to the streetlights outside. This process, from nuclear fission to electricity, is constantly ongoing, ensuring a steady flow of electricity. And the best part? The only byproduct is steam, making nuclear power a clean and efficient source of energy. So, we've successfully transformed the power of the atom into usable electricity. We've journeyed from the heart of an atom to the electricity in our homes, all thanks to nuclear power plants. It's been quite the adventure, hasn't it? Let's take a moment to reflect on what we've learned. We started with the concept of nuclear energy, a force so powerful it can light up entire cities. It's like harnessing the energy of a star right here on Earth. This mind-boggling power comes from the tiniest of things, atoms. Specifically, the nucleus of an atom, hence the term nuclear. The fuel for these plants is a mineral called uranium. This isn't your average fuel. Unlike coal or gas, which burn and are gone, uranium undergoes a process called nuclear fission. This is where things get really interesting. In nuclear fission, the nucleus of an atom splits into two smaller nuclei, releasing a massive amount of energy in the process. And that's not all. The newly formed nuclei go on to cause more fissions, creating a chain reaction. It's like a domino effect, only with atoms and energy instead of dominoes. This chain reaction is what powers nuclear power plants. But we don't use nuclear energy as it is. The energy from the fission process comes out as heat. This heat is then used to produce steam, which drives a turbine connected to a generator. It's this generator that produces the electricity we use in our homes. So, from the splitting of an atom in a power plant, through a chain reaction, to heat, to steam, to a spinning turbine, to electricity, it's an incredible journey that energy takes. And all of this happens out of sight, in the heart of a nuclear power plant. Next time you switch on a light, remember the amazing journey of energy, from the atom in a nuclear power plant to the electricity powering your home.